Have you ever stared at a math problem, one of those ones just packed with X's and Y's, and felt like you were trying to read a secret code? Well, that's polynomials for a lot of people. But here's the thing, it's not an unbreakable code. It's a puzzle, and once you have the right tools, it becomes something you can totally master. So let's get into it and crack this code together.
And yeah, if you're feeling a little lost in that sea of variables and exponents, trust me, you are not alone. Our whole goal here is to take that feeling of confusion and flip it into confidence. I promise by the time we're done, you'll be navigating this stuff like a pro.
So what's our game plan? Well, we've got a really clear roadmap. First, we're going to start with the absolute basics, the building blocks. Then, we'll get into how to find the zero. That's the magic number that solves the whole thing. After that, I'm going to let you in on some secret shortcuts that'll save you a ton of time. We'll get into factorization, build up your toolkit of formulas, and finally, we'll cover the common traps so you know what to watch out for. Sound good? Let's go.
Okay, first things first. Before we can solve the puzzle, we have to know what the pieces even look like, right? So let's answer the big question. What exactly is a polynomial?
Let's just boil it right down. A polynomial is basically an algebraic expression that follows one very important rule. The exponents, the little numbers on the variables, have to be whole numbers. So we're talking 0, 1, 2, 3, and so on. No fractions, no negative numbers. That's it. That's the secret handshake to get into the polynomial club. And this slide right here makes it super clear. Over on the left, we've got legit polynomials. Notice the exponents are all good whole numbers. But look at the right. These guys are imposters. Why? Well, that square root of t is really t to the 1/2 power, not a whole number. And that 1 over x, that's just a sneaky way of writing x to the -1 power. So nope, not polynomials. It all comes back to that one simple rule. Okay, another key term you have to know is degree, and it's so simple, but it trips a lot of people up. The degree has nothing to do with how many parts there are. It's just the highest, the biggest exponent you can find on a variable in the whole expression. So in this example, you scan through, you see a 7, you see a 6. 7 is the biggest. So the degree is 7. That's all there is to it.
Now, based on that degree, we give these polynomials special names. If the degree is 1, we call it linear, because it makes a straight line on a graph. If the degree is 2, it's a quadratic, and that gives you that classic U-shaped curve. If the degree is 3, we call it a cubic. These are the big three. You're going to see them everywhere.
All right, now that we know what these things are, let's talk about how to solve them. And that brings us to this idea of finding a zero. You can think of it like this. A polynomial is like a machine, and the zero is the one input, the magic number, that makes the machine's output drop to 0. It's kind of like finding the off switch.
So here's the official definition. A zero is just the number you can plug in for x that makes the entire polynomial equal 0. You might also hear it called a root or a solution. They all mean the same thing. It's the answer to the puzzle. And finding it is one of the main goals when we work with polynomials.
Let's see how it works with a super simple one. To find the zero here, all you do is take the whole thing, set it equal to 0, and then just do basic algebra to solve for x. So you subtract 1 from both sides, then divide by 2, and bam, x equals -1/2. That's our zero. That's the magic number for this polynomial.
Okay. Now for my favorite part, the shortcuts. There are these two amazing theorems that are basically algebraic life hacks. Once you understand them, you can solve certain problems in a fraction of the time.
So I'm sure you remember polynomial long division from class, right? It totally works, but let's be real. It's long, it's tedious, and it is so easy to make one tiny little mistake that messes up the whole thing. But what if I told you there's a way to find the answer without actually doing the division?
This is it, the remainder theorem. And it is absolutely brilliant. It says that if you want to know the remainder when you divide a polynomial by something like x minus a, you don't have to divide. You just take that number a, plug it into the polynomial, and whatever answer you get, that's the remainder. It's a total game changer. And right on the heels of that comes the factor theorem. This is just taking that last idea one step further. So what if you use the remainder theorem and the remainder you get is 0? What does that tell you? It means that x minus a divides into your polynomial perfectly with nothing left over. In other words, you just found a factor. It's an amazing way to check for factors super quick. So, finding factors is a huge deal. Factorization is just a fancy word for breaking a big, complicated polynomial down into its smaller, simpler building blocks. And it's a skill you absolutely have to solve more complex equations. One of the most common ways to factor a quadratic is by splitting the middle term. So here's the puzzle.
You need two numbers that add up to the middle number, 17, and multiplied to the same thing as the first and last numbers multiplied together, so 30. Little thought? It's 2 and 15. So you rewrite the middle term using those two numbers. You group them up, and you'll magically see a common factor pop out. Then you just pull it all together.
All right, if you really want to level up your speed and skill, you need a toolkit. And that's what algebraic identities are. They're like special patterns that, if you can spot them, let you factor or expand something in a single move, no long process needed. Think of these next couple of slides as your ultimate cheat sheet for polynomials. Seriously, if you get to know these formulas, they will save you again and again. They really are your best friends in algebra.
First up, the must-know quadratic identities. We've got the square of a sum, the square of a difference, and the super useful difference of squares. That one is a lifesaver for factoring. And then the square of a three-term expression. Get these into your brain, you won't regret it.
And here's the next level, the cubic identities. Yeah, they look a little more intimidating, but they are so powerful when you're dealing with those degree 3 polynomials. Honestly, this is a perfect time to pause and grab a screenshot. You're going to want these in your notes.
Okay, let's wrap this up by talking about how to avoid the common traps. One of the best ways to get better at something is to know the mistakes everyone else makes so you can sidestep them completely.
The two biggest villains are sign errors and messing up the distributive property. It is just so easy to lose a negative sign when you're moving things around, or to forget to multiply the term outside the parentheses to every single thing inside. The fix? It's not glamorous, but it works. Slow down, double-check your signs, and if it helps, literally draw little arrows to make sure you distribute to every part. It'll save you so much grief.
So let's do a super fast recap. What do you need to remember? 1. Exponents have to be whole numbers. Period. 2. The degree is just the biggest exponent. 3. A 0 is the number that makes the whole thing equal 0. 4. Use the remainder and factor theorems as your secret weapons. And 5. Memorize those identities. If you can lock in these 5 things, you are well on your way to mastering polynomials.
So there you have it. You've got the map, you've got the toolkit, you know the secret shortcuts, you are ready to crack the code. The only question left is, which problem are you going to go solve first?